As you mentioned, my name is Brandon Roberts. You can follow me on Twitter. I like to tweet about basketball and blocking people sometimes, and and sometimes Angular stuff like that. So you can follow me there. I'll try to follow you back. Here's another picture of me. I work on the Angular team doing documentation and development for Angular.io, and I also work on the NGRX project. And I wanted to give this talk, Angular, NGRX. I wanted to give this talk to cover two powerful pieces of state management with NGRX. So let's talk about what I'm going to cover here. I'll give an overview of what NGRX is in Angular if you're not that familiar with it. I'll talk about selectors and how to use them efficiently, and also talk about effects and how to take more advantage of them. So as a refresher, NGRX is a set of reactive libraries for Angular. NGRX at its core follows the Redux pattern. From the diagram, you can see actions express interesting events that happen within your application and represent a logical change in state. Actions are dispatched, and they're handled by a special reducer function that handles that action and computes the next state. This state is delivered to your components as an observable. And just to mention, this state already exists in your application, whether you're using NGRX or not. But NGRX provides an architecture for handling complex state management requirements. So first, I want to cover selectors. So I'll talk about what selectors are. I'll cover the different types of selectors, and we'll get into some practical examples of how you use selectors. So selectors are one of the best parts of NGRX, and we'll get into why. But first, let's define what they are. So what are selectors in NGRX? These are what selectors are. Your application wants a piece of data from the state. Selectors provide that data. Okay, maybe selectors aren't exactly like this. Selectors are just functions in NGRX. There are string selectors in NGRX, but this talk is gonna focus more on selector functions and the things that go along with them. Your state is one big object with a lot of data structures in it, and selectors help you use that data. So if you looked at the interface for a selector, as I mentioned, selectors are provided your whole state object, and they can return a result. And these selectors are also type safe if you're using if you're using Angular, you're using TypeScript, so you get that type safety on top of that, so you can verify the shape of the result. So if you have selectors, give you an easy way to slice off pieces of state and allow you to worry less about the overall structure of your state and just focus on what you need to get out of it, whether you just need to get a small piece or larger pieces. And there are two types of selector functions, getters and derivers. So getters are simple functions. They usually live with your reducers, and they only operate on small, specific pieces of state, if you're familiar with the Redux pattern. So if we look at this login page state interface, it just has a couple of properties. So let's look at how you could use a selector as a getter function to get one of these properties, and we'll build off that later. So as I mentioned, the login page state has a pending property. So to select the pending state, each function, you would provide a function that will be provided that login page and then return that pending property. Now this is a small function that can be reused across different composed selectors. And as I mentioned, we can also use selector functions to derive state. Now you could think of derivers as more complex getters. They're responsible for transforming derived state. So first, what is derived state? Well, it's state that already exists in the store. There's a lot of information that you already have from data that you can gather in the store. when you're building views, these views are going to be composed of many different sets of data, whether it be customers to customer orders or any complex data structure that you may need for a given view. So if we take a look at this user model interface, it only has a few properties also, but we'll take a look at it in the context of managing users. So here's an example interface of a state that would track users. We're tracking the IDs of each user, along with a dictionary for looking up those users. We're tracking a selected user from the collection, the number of users, and active users. But we don't need to capture all these properties separately. We can derive some of these properties already because the selected user model already exists in the state. The number of users already exists. The number of active users already exists. So we could derive those pieces of state from that information already there. So we can remove those additional pieces and add a different property to reference the selected user ID. And we would do that using selectors. If we take a look at another example, we have a user model interface that would contain what would be returned from a backend upon successful authentication. Our auth state would capture that user and hold any additional properties that the current auth state that you would have to share. You notice there isn't a notion explicitly of being logged in the auth state. So we would use a selector to derive that. Whether the user is being logged in can be derived from the user information itself. Here we're selecting the authenticated user from the auth state and turning that user into a Boolean that we can return in our component or use when we use this selector. When the user logs out, that user information is cleared, the selector returns false, and all that happens automatically just because when the selector is fired. And this happens efficiently because selectors are memoized. So memoized selectors, if we take a look at a selector function on its own, it doesn't do any caching or checking for results. Calling this function will compute these results every time. So combining these multiple result selectors in this way could cause performance issues. When combined with selector creators using this create selector function, the selector function is memoized. So memoized selectors only fire when the arguments change. The arguments for the memoized selectors are checked before the projector function is called. So in this example, the collection of books will only produce a new set when an item from that collection is removed or added or updated. And that allows it to be more efficient. So if we look at a bigger example of selecting a user profile, and I'll go through and break down how we will build this type of selector in a minute, but each selector will be tracking its own arguments. All the arguments are checked for changes, and instead of the selector firing each time one of the arguments change, it waits until all the arguments are evaluated before the projector function is called. So in this case, we would only get one call instead of 3. The example I just showed you was how you can use selectors to compose these multiple sets of data. Creating selectors takes up to eight arguments total, but these are built up of smaller selectors. So let's look at an interface we have here of books and users, and we'll show you how you can build up a complex model based on these smaller pieces of state. And selectors aren't aware, or they don't mind whether this state is loaded eagerly or lazily. They're just responsible for combining that to form new data models. So looking at a selector for the users, we will start from the top level state and get the users, and we use the projector function to get the user entities. For a given user, we would compose another selector to get all the selectors, not all the users, and a specific user that we want to get. So these selectors are reusable, so composition of them is easy. So then we go through and look at an example of selecting books. It is similar to selecting the user entities. We will select the top level book state and then use that to return the book entities. If you're using something like NGRX entity in Angular, these selectors will be provided for you. So now we can combine those two selectors together to form a new data model. We take the user's book IDs and the books, and we map over each one of the book IDs and return the related book for that information. These data sets don't have to be stored together, but like I said, we have derived a new set of state to consume. Selectors, like I said, selectors are building blocks. We can select the current user. We could continue to select users' books. We could select favorites, all into one view. And this would be done efficiently in a reusable way. Memoized selectors can handle many common use cases just out of the box. But selectors can also be customized to fit your needs in case that you need more advanced usage. As I mentioned before, memoized selectors can take up to 8 arguments in a projector function. But what if you need more than 8? What if you need to change the memoization strategy? I had a person ask that said they had a really complex data model where they wanted 20 entities that they wanted to manage it with in a given selector. And the answer to that is to use selector factories. The create selector function out of the box gives you defaults for memoization that you can use with these selectors to combine together, but it can be customized. You can tailor your memoized selectors to fit your needs with using your own selector factory. As I mentioned, out of the box, these selectors check against the results and the arguments before returning whether it should return the current value or return a new computed value. But let's say you wanted to check let's say you're returning an array and you want to check that every item in the array is still the same even after you've computed the results. You could use a more advanced memoization strategy for that. So next, I'll talk about effects. And following the same pattern, I'll define what effects are, cover the types of effects, and get into some practical examples. So what are effects? Effects are a side effect model for a store. And if you've used Redux, you may be familiar with like Redux Observable. It's the same idea with effects in Angular. So let's break that down a little further and talk about what they do. So this is the first encounter that most developers have when they use effects. And I'll say, why is that? And because NGRX is about indirection, where if you're traditionally using Angular, you're usually tying your components to your services and performing these tasks. But in NGRX, you delegate these intents and tasks instead of handling them directly. So to break down how that worked, we can look at what life was before effects. Here we're listening to a stream of actions or filtering down on each action and then mapping that into an API request. Based on the result, we return a new action and subscribe and dispatch that action to the store. That's easy, right? But what if we have to do this over and over? Subscribing to the store. I didn't even handle unsubscribing to prevent memory leaks. So the sauce in effects is in the effect decorator and an of type operator. The repeated setup of filtering and subscribing to the store is handled for you in a type-safe way. So you don't have to deal with boilerplate. So how do these effects relate to actions? So if we look back at the diagram, actions have a one-to-many relationship with effects and reducers. Just like every action hits every reducer, every action hits every effect. Now, whether you do something with that effect or not depends on what you're doing with that particular event. So you use effects as listeners of actions as sources of actions. Since effects listen to every action that is here, that it hears after it hits the reducers, then you can perform some tasks based on that. And they also, since it's after the reducers, you get the latest state in case you need to make some decision based on that. So we can make a comparison of how state changes make a clear distinction from effects. If we talk about a reducer, state changes, reducers take the current state in action, hit the reducer and form a synchronous task and return a new state. And as I mentioned, all that happens synchronously. We can model that same flow with effects, but it's slightly different. From the dispatched action, effects handle that task, and this happens asynchronously. The best part is your components are not bound to wait on these tasks to finish anymore, because your components are only responsible for consuming selectors from your state, and they automatically get updated when actions are dispatched and state changes. And then we have a new action in and an action out. And that's the general rule with effects: action in, action out. So you can use effects to handle tasks that will produce or maybe not produce new actions. A good example of this is to use a file upload task that handles progress. So we can walk through how we would use this with an effect to listen for this file upload action. So if we go back here for a second, if you look at the file upload page, the user has submitted the file upload event, and now I want to handle that task. So here's just an example of using Angular's HTTP client that actually provides progress events for you. So you could combine that with an effect to listen to those progress events. And this could in turn turn into one or more actions based on whether the upload starts, progress ends, or an error happens. You can also use effects to perform tasks in parallel. Since every action hits every effect, we can do things simultaneously as far as handling the file upload and displaying a file upload progress dialog while that upload is happening, since both of those are based on the same action. Some effects don't need to return new actions. In this case, I'm using an effect to listen for a login success action from the API and to navigate the user to their destination of choice. This is an effect this effect only performs a side effect, but it does not return a new action. And the key here is the dispatch false. This ignores any actions that come out of this effect, because if you don't do that, it'll lock up your browser. And friends don't let friends create infinite loops. So we have effects as listeners of actions and producers of actions. But what about side effects without actions? If we take a look at the diagram again, if we take away the action stream, what do we have? Well, we still got side effects. Effects are just a message bus that's always listening. Side effects can exist without user-initiated actions. You can think of browser events such as mouse movements to track activity, WebSockets, or even change detection in Angular. And we can do that because it's all streams. Effects are listeners of streams that can perform tasks and transfer them into actions that are subscribed to the store. So any stream can be a source of input to the store or used as an effect as a source of input. So here we can tap into the Angular router stream of router events and subscribe those events and map them to actions. You use these for like global lists, global spinners, and other events that you want to listen to that aren't necessarily triggered by the user. And you don't need any actions at all to trigger these events. So to recap, I talked about injects in general, selectors and what they are and how I can use them, how they're composable and efficient, and effects to delegate intent, handle tasks asynchronously, and to perform or return new actions. Thank you for allowing me this opportunity. If I could just plug Injurex's platform, we always welcome contributions to the project, whether it's documentation, tests. Injurex continues to thrive because of the community. Thank you.